All right, looks like we've got a quorum. Why don't we get started? So, welcome to CDM for May. Today we've got two topics on the agenda. The first one is optimizing the OSD map for client uses. Kifu, do you want to take it away?
Yeah, let me start with motivation.
Hmm?
I explained it briefly over the main list, but I'll repeat it in this meeting. So the problem is that in a there are typical use case in a RIP-fast cluster, for for example, a all-flash cluster. It just completes a rebalance or recover. The rebalance completes very quickly, and the rebalance leaves the cluster with a lot of OC maps. But before that, before before that, some cluster didn't get a chance to pick up these updated maps. They're far behind of these updates of this OC map. So these clients with ancient OC map in their hand, they awaken randomly, and for talking to the cluster, they want the latest OC map, and then they're talking to monitor for subscribing the latest OC map, and for serving the latest OC map. There are a lot of them. Please bear this in mind. So this monitor will be very busy occupied with loading the, the OC maps from RocksDB and encoding them in large batches. While discussing this problem with one of the contributors from the community, the contributor mentioned that in their case, the total size of the incremental OST map could be up to 200 and 300 megabytes. And before the monitor completes serving the OST map, the cluster is basically unresponsive. So there's a couple alternatives out here. One is the original one posted by the contributor. He wanted to add a setting to limit the versions when building incremental OC map. So when the numbers or total size of incremental OC map exceed the pre-configured setting, the client will ask for, instead of asking for the incremental map, it will ask for the full map in hope to reduce the total size of the traffic and the number of the OC map encoded by monitor to leave the burden of the monitors and also the clients, because if it get to the point where they could decode the OC map, it should decode all of them, right? And apply it over its ancient OC map. And the second option is proposed by me to use the finer grained logs in monitor in hope to have a more parallelism in the monitor when it serving the for example the OSD map. I think that's a one use case. Probably there are more, because we did this before to encode the to update the mapping of the PG to OSD. But Greg sent a mail to explain his concern, because inherently the monitor need to access a single data structure of the RocksDBs for writing to updating the RocksDB and for reading from it in the pre-processing stage even. it reads from the OSDB in pre-processing stage. So to use a finer grained lock is very scary in this perspective because we really need to lock the RocksDB when accessing it.
Well, so do you mind if I ask a couple questions? So we're specifically concerned about the scalability of the monitor serving OSD maps to clients, right?
Yes,
That's not a
the
locking
case.
problem. It's just a read. Greg's worried about trying to parallelize updates, which is not relevant here. And it also means that finer grained locking is also irrelevant here. All we need to do is slightly change up the way we serve requests for OSD maps, not access any of those data structures in the first place. So Greg's right. We don't want to add fine grained locking to the monitor because it won't solve any fundamental problems. But that's not relevant here anyway. Secondly, we don't get faster with more monitors. So I disagree about your characterization that increasing throughput at the monitor is the more general solution. The more general solution is to reduce the work the monitor has to do in the first place. And in this case, I think this is even easier than the original proposal makes it sound. The reason why we ask for a sequence of OSD maps in the client isn't actually because incremental OSD maps are smaller. It's because the client needs to see the delta between different maps to determine whether ops need to be resent. So in the case of a quiescent client that has no outstanding ops in the first place, Josh can correct me here if I'm missing something, but I think that's it. We never need the intervening maps. So if a client wakes up, it has no outstanding ops, and the newest map is more than, 2 away, we should always just request the most recent and be done with it. I think that will always suffice.
Yeah,
So
you're correct, Sam, about the QSN clients not requiring incremental updates.
So I think the two best solutions here are to modify the client to optimist or to notice when it doesn't need the intervening maps and make a point not to ask for them. And secondly, to change up the OSD map requesting pipeline on the monitor to be more parallel. That should be straightforward. I don't think there's any way that it could cause problems. The only exception would be that the monitor needs some kind of widely available, internally published notion of the most recent monitor map. But even that can be allowed to be somewhat out of date. So an RCU-like solution should do the job.
RCU, but because the amount of the number of those maps, RCU will need abundant of the memory for holding all the maps. Otherwise, it won't work.
No. We can read them out of RocksDB. We don't have to hold them in memory. It's just that if a client requests, quote, the most recent, unquote, map, we need to know what that is. That's the only piece of shared mutable state that this theoretical parallel OSD map serving process needs to worry about. And even that's allowed to be out of date, so it doesn't even need to be perfect.
And which part of the OSD map serving is expensive? Is it encoding the map or is it fetching it from RocksDB? We have the in-memory cache already.
I presumed that it was actually dominating the primary monitor blocks. So the goal here isn't so much to reduce the cost, it's to get at the hell out of the monitor update bottleneck.
Right.
I think we've seen clusters where it actually is just that the map's big and it takes a long time to encode and decode from the various buffer lists we have it in.
Yeah, like the example where you had 200 megabytes of total incrementals. Encoding all that will take some time for sure.
So a bigger in-memory cache of decoded maps would help too.
By the way, there is a third.
Because you have to re-encode it to send it out. So actually, can we keep cached copies of the encoded MOSD map structures? So that we just do a buffer list reference?
Yes, but I think we already do that, and part of the issue is just about how many clients we have across different versions. I'd have to check. I could be misremembering that.
Yeah, we do have to re-encode for different versions of clients sometimes.
True.
Yes.
But we can keep the most common.
Yeah.
But there's a third alternative.
Notice.
Hold on, but there's a third alternative which is proposed by Ilya. He suggests that we could cut down the size of the incremental map, which only encodes the interesting bits by client, because we have two sections in encoded map. One is for the client, another is for OSD in general.
Xinfo, I believe. is always uninteresting to clients, if I recall correctly.
Yeah.
I think there's some other stuff too. Yeah, that's true. So that's 4 distinct things we can do to solve the problem.
Yeah.
But I think the biggest, most important one is that clients that don't need intervening maps shouldn't ask for them. That's the most important one. That'll cut down the total amount of work we have to do in the first place.
That's the thing we can do, but it doesn't help us with existing clients in the field, and I'm actually not sure it's the most important in these generate cases. Because clients are like, a lot of times, like when this is a problem, it's usually because there's a lot of cluster change happening and the clients are like trying to get writes through. So actually, I think probably the smaller map for clients is the simplest thing that will be
Wouldn't
most
that
impactful to
also
start with.
require a client change?
Yes.
Yes. But
And we can look at trying to parallelize OSD map answering requests, but
That honestly seems
like
pretty easy.
we probably another way to follow this way is to audit all the clients to see if they are really decoding the other parts of the OSD map.
No, we agree. That would help. Reducing the
What
size
about
of the OSD map is one of the things that will help. Yep.
what about when does the client request it from the map from the monitor versus getting the map automatically from the OSDs when it tries to talk to them?
Forgot about that.
Like I thought it was only the case that it asked the monitor for the map if it wasn't currently doing I/O to OSDs or was very out of date. Does anybody remember the exact?
That's right. The OSD is supposed to like preemptively send it the maps.
Yeah, the OSD shares the
Yes.
map.
No, but I mean that's
Yes.
in the normal case. If you find out from the OSD that you're out of date, you also find out the new maps. I'm trying to
Right.
think of the case where. When do we ask for?
I think there's a lot.
Is it
I
on
think
a
we'd have to
timeout?
audit this because like the rules have varied over the years, and so I think there's a lot of overlap where the clients ask for it and the OSD sends it for them, so the clients are doing duplicate requests.
That sounds like that actually is the first thing to check. It could be that there's a bug that's causing us to go to the monitor when we don't need to.
Like asking OSD for incremental maps.
No, the OSD is supposed to provide them on its own.
Whenever
Like as soon as
it gets an app from the client, it'll share the map if it has a newer OSD map than the client does.
Right.
But how can the client know which OSD should
That's what I'm saying. For the client to know it's out of date in the first place, someone has to have told it. So in the case that it's an OSD that told it, the OSD is supposed to give it the maps it's missing at the same time. So we need to know under what conditions this is happening to the client. Like, is it that the client sent a request to the monitor and that's how it found out? Or is it that the OSD is not correctly sending the maps? Or is that the client isn't waiting for the maps from the OSD?
I think it's the first case because in the very case
I mean,
of
we
the
should find out.
contributor, they were using a KCFS client, which does not keep a long-standing connection with the monitor or any of the OSD. But when it's wake up, it tries to grab the latest OSD map and
just like every time.
Monitor.
Maybe this is a specific behavior of the kernel client.
Yeah, but
Yeah,
then
that could be right.
yeah, but then when it tries to connect, it should just get the entire map, right? Why is it trying to get incremental maps at that point if it is already out of date?
I think this is the way how monitor works.
No, there are several different ways to ask the monitor for a map. This is only the one you're describing is only one of the behaviors that the monitor has. So it could be that it remembers the map it last had, and every time it wakes up, it always requests all of the maps back to that map, whether it needs them or not.
I think we need more details from the person with the giant OSD maps because, I mean, it doesn't take very many requests from that for a map that size to overwhelm things. But in general,
a total set of maps that big, I think. I don't think
or even just one from a bunch of clients trying to keep up.
But that's not the behavior described. He was saying that this particular client was unresponsive for a long time as it caught up. If I interpreted the initial report correctly, when Kifu.
Perhaps I
started from the
misremembered
beginning.
it, but I thought a big chunk of it was just that the monitors weren't doing anything because they had a bunch of OSD updates pending and a bunch of OSD map requests incoming.
Anyway, it sounds like we need a finer grade understanding of what the behavior was.
Kifu, maybe we can ask the person who reported this to create a tracker with all the associated information we're looking for.
It's on the meeting. Simon, would you want to explain the use case in more details?
The use case and the observed behavior.
Probably has some difficulty.
You say it was Simon?
Yes, he was actually author of the PR I posted
Okay.
in the pad.
Simon, if you can hear us, we'd love to know more details about the situation that you observed.
The fix or mitigation depends on some variables that aren't clear.
All right, so looking at the pull request, it seems to be idle CephOS clients will not get the latest OSD map. There was no request to accept the monitor client's tick. And it's recovering SSD cluster. So there's a lot of actual traffic happening.
Yes.
Yep, that's my understanding from what.
Yes, correct.
At the beginning.
Yeah.
So
which would
in a slow cluster, we won't have that many of the OSD map before the client can catch up with the cluster.
Right. So the fix there is trivial. The client should always request the most recent map, and that's it. If there are no outstanding IOs, that will fully solve that specific behavior. But if that's not the only behavior in question, then it won't suffice. So. No.
Okay. So let me summarize the discussion a little bit. So the first thing might be we need to do is to define to understanding the behavior of the client, why it would need to ask for the incremental map, even though we offer the protocol in which the client is able to ask for the full map when it's far behind the cluster OSD map epochs.
If it's far behind and it has outstanding IO, then we ask for the intermediate.
No,
I know.
It should not have outstanding IO because it has been quiet for a long time.
Idle. You said far behind.
Yes, idle.
I'm saying idle is important here. Because if it's not idle, then we know that it's supposed to ask for the incremental ones. Arguably, that would be a behavior to fix as well. But in the special case where it's idle, we don't even need that. I was just filling out your summary. Or adding that detail. The idle part is important.
Oh, connect to the Etherpad anymore. Need a latest map instead of all. Okay, I see you updating the Etherpad. So if this is the existing behavior of the KCFLS client, we need to fix it so that the kernel client can ask for the latest map. It's very likely what is proposed in the pull request, but it's trying to fix the add a setting to do this.
I don't really want a setting for this. I'd like to change the default to be correct all the time.
Yeah. So then, okay. So if we are able to update the behavior update the client to address this problem, we can dispense with all the changes on the server side. to serve to either parallelize the processing of the OST map or
this pull request is monitor side. I don't think you can do this. Yeah, this is monitor side. You can't do this in the monitor. You need to change the client to ask for the right thing. If the client actually asks for those versions, that's what we have to give it.
okay.
At least that's my guess.
Okay. I think that's it.
Okay. Sounds good.
I was wondering why go through all the trouble updating the monitor side to address the problem from the client. And because he also updated the client to get his problem fixed. Anyway, I will talk to him offline to find out more details, and I get you update you guys over the mailing list.
All right, thanks.
Cool.
Sounds good.
Yeah, but before we move to the next topic, I was just thinking the idea of the lighter weight OSD map is also not bad. In general, we need to probably explore whether that's needed, not needed, or how far can we get with that.
But that would need to update the protocol so the client can subscribe for a customized version of the map.
Yeah,
and
probably,
it's not
yes.
backward compatible.
Well,
In
I
the
mean,
sense that
it depends what it's using for today. If it's not decoding those sections like the xinfo, then it doesn't need them in the first place.
Yeah.
It does decode them because we use the same libraries to decode clients.
It's possible that we
Or
could do a
decode
backwards
the map.
compatible decoding that says there's 0 xinfos though, or something like that. I don't know. I think we'd have to look into it in more detail.
Yeah.
Or if it happens to be the case that they don't access any fields introduced after a particular version, then it's super easy. Summon the old version. So there may actually be, admittedly hacky, ways of getting around that problem.
Why it would be hacky?
Well, it's hacky in the sense that it's not how the protocol was intended to be used. It will just happen to work. We'll have to be extra careful, for instance, about retiring those version numbers.
And with kernel clients as well, because the kernel clients don't have the same exact versions.
So it's permissible. It's just that we'll be overloading some things we did in the future, so we'll have to be extra careful.
Mm-hmm.
Yeah.
Oh, you mean we just change the behavior of monitor? So instead of serving the full version of the OST map, we just serve the partial version of OST map without changing the protocol, right? You know what I mean?
Well, if we happen to have a version number in the past that encodes everything that the client currently uses and happens not to include a bunch of big stuff that it doesn't need, then if we send the client that version, it won't decode stuff newer because it won't be there, and it will work correctly, even though it wasn't designed that way. So in that sense, it will be hacky, but it would work.
So for instance, if, and I stress if, because I think there are some things it needs, but if the client doesn't need anything out of the extended OSD attributes, we could set the extended OSD attributes version to 0 or 1 or whatever that is the minimal size while maintaining the rest of the OSD at its current state, or the rest of the map at its current state.
I think we can just audit the behavior of all the clients. I think that kind of trivial. It's just mundane work to understand what bits it is interested. And if it's only interested in the first part, I think we can just skip the second part when serving the. But we cannot differentiate the client by looking at its an entity, because as Ilya mentioned that for example, Ceph CLI uses the client, but it wants the full version of the OST map. That might be an exception, but we have no way to differentiate to tell if the client is Ceph CLI or not, or it's a KCFS client.
Yeah, and it's also made tricky because the kernel clients needed to decode stuff, but were more selective about which parts they paid attention to.
The thing is,
we intended for clients not to look at the extended OSD info, but a bunch of them did. But then they ended up looking at bits of it anyway because we put stuff in the wrong place.
Yeah, otherwise we need to update the protocol
which
for a
fields?
new situation.
I have no idea anymore. I just know that it came up at one point.
But also, we don't need to restrict ourselves to changes that don't change the protocol. We can actually fix the clients.
Mm-hmm.
It's
Yes,
an annoying change, and it will restrict our ability to correct this in the short term. But as far as I know, this is only a modestly sized problem. Yeah. And if we need to do something drastic in the short term, we can do that too. But we should definitely address creating a cut-down version of the OSD map with only things the client cares about. Also, splitting the OSD map into a version encoded for OSDs and a version encoded for clients will actually make maintenance easier. We won't have to be nearly as careful about adding stuff to the OSD map, and it will be a lot easier to deal with.
Yes,
kernel client.
I would like to do that.
So it's worth doing independently of this problem.
If we want to go that way, does the steps I enlist in the mail make sense? I could paste it in the.
I mean, we also need to change it so that idle clients only request the maps they need. Because again, the one thing we really can't, distributed system our way out of is monitor throughput. So anything we can do to reduce the amount of load on monitors is worth doing. So I think we should do essentially all of the things discussed here, just perhaps not at the same time.
Yeah, I wouldn't say everything is highest priority, but I think we've seen one real problem, which is solved by the latest client change, and the further optimizations can improve the ability of the monitors to.
So yes, I think the features of a CMAP client thing would make sense. Ifu, to answer your question.
I'm trying to figure out the exact step we should follow if we want to implement the current version of the OSD map. Before that, I want to have your opinions on this exact step if we want to go this way. I'm updating the Etherpad with a step in the very end.
I think what you've outlined is a good approach. It's just that the details will depend on exactly what things are going to be on both the client and the server side version of the map.
Yes.
So identifying that very carefully and then being yes, this solution works, or no, there's something a little trickier that we need to deal with is, I think, the way to go.
Yeah, I think step 0 is auditing the clients to understand what they need from the maps.
Yeah. Other than that, I think it's pretty simple. Any client that advertises support for the cut-down OSD map gets the cut-down OSD map, and that's kind of it.
Okay.
We'll probably encode it. It's not like we keep two versions of the OSD map on the monitor. I think we just encode on the fly a cut-down version of the relevant map.
Hopefully, yeah.
Or maybe not. Maybe we keep cached versions of it. I don't know. I'm ambivalent.
Yeah.
But
I thought we kept caches of different versions already.
That might be. Sorry, I meant of different and the version's the wrong word here. Of different encoding types.
Yeah.
That is,
yeah, so
version 141, we might keep. Oh, we keep more than one encoded version of that for.
I believe so.
Kernel client and normal, for instance.
Or just for whatever feature bits the client advertises, because they differ across versions as well.
Oh, neat. Okay.
We can even update the layout of the full version of OSD map, so we can put the client-only OSD map at the.
We don't have to do that though, and we shouldn't bother. I don't think that's important. It's a different encoding.
Cut down the memory footprint of the OSD map cache, right?
There's no reason to relate them. We would just cache two different copies. If we add that as a requirement, it creates dependencies between fields updated in the client OSD map and the ones updated in the server. I don't think it's worth it.
Yeah, I'm worried about newer clients with older OSDs because the newer clients have extra fields that the older OSDs don't.
We should just very
boringly trying to spare that space.
Two different derived encodings of the same thing.
No.
It's just easier.
I thought the servers always need a super set of the bits than the client version.
That might actually not be true. It's possible that we might introduce a field that's interesting for both clients and servers, where the client is new enough to get the field, but the server isn't, because we're in an upgrade situation. So it'll be often true, but I don't think it's strictly true.
Okay, makes sense to me.
Yeah. just in this example, there were things like whether clients the force resend operations flags. I think there would have been situations where the monitors could set that and get the correct behavior on the clients without changing the OSDs at all.
Heck, we could actually choose to encode fields in the client map that don't exist in the server map as a summary or something. So I don't think we should assume that it's a superset. I think we should assume that they're deterministically derived encodings.
Yeah, and actually, if we're depending on the options we take with Crimson messaging, for instance, there's a good chance that we'll want to do that.
Yep.
So basically, it boils down to a new subscriptions from the client whenever it wants in the newer version of a custom smaller version of a host map, he need to ask the monitor for such kind of a host map.
Yeah, I mean, or
okay.
Yeah, that sounds right.
Yeah,
I
think we want to do that so that's like the monitoring
right?
applications. Yeah.
It solves the Ceph CLI problem as well.
Yeah, and it'll be good for like if the MDSs or other privileged server clients need to do weird stuff.
Yeah.
Okay.
Then that's much less of an issue.
Yeah, as a client might want the version for whatever reason.
Thank you, guys, and I think that's it.
Cool.
All right, thanks a lot, Gifu. Great discussion.
Yeah, monitor throughput is kind of one of the most important things. It's always good to discuss.
Yeah.
All right. So the next topic, unless there's more on this one.
I was just going to make a note that even Sam brought up a thing about using LRUs for answering OSD map subscriptions requests, and I'm not sure if that's a problem or not, but I would want to look about what happens when. So what? And maybe this isn't a thing in the monitor because I can't remember. But what happens if you send it an update request followed by a get latest map on all of the same client?
As long as the serving process is monotone, then it's fine.
Maybe? No, I'm saying right now
it is fine. As long as it forces a synchronization point, it's fine. Really.
Okay, sorry, yes. So I'm saying that right now I'm not sure, but we might depend on that synchronization point, and that would be really
I'm saying we can afford
really
a synchronization point. It's okay.
Okay.
The synchronization point is fine. It will be not a problem.
All right.
It's not a full synchronization point from the publishing side. It's only a synchronization point on the consuming side, and that's not a bound resource here.
Okay.
In any case, it sounds like that's a lower impact change than the other pieces that we discussed.
Well, it solves a different problem. In cases where the bottleneck actually is the monitor running out of resources, then the most important thing would be to increase monitor throughput. So it depends.
Yeah,
I would rather focus on the maps right now, yes.
I agree. I'm just saying, if we did see reports where the primary problem was OSD map requests bogging the monitor down, then that would be the thing to address.
Yeah.
All right. So let's move on to the second topic then. This is about being able to blocklist entities or by a label or by a generation number or some mechanism for blocklisting things across a whole site, but still being able to bring the site back. So I think Shyam brought this up. So do you want to explain more?
Yeah, sure. So we sort of discussed this in December CDM. So I'll start with the motivation here, which is more covered in the mail sent to the mailing list. So this is basically for disaster recovery where there are two Kubernetes clusters, or in other words, two client clusters, Ceph client clusters that share a common Ceph storage endpoint. Ceph storage cluster in that sense. And applications that have RBD images or CephFS subvolumes mounted on client cluster A could be recovered on client cluster B because client cluster A is no longer accessible, and or just the application on client cluster A is no longer accessible. I mean, the boundary of disaster is either the entire cluster or just an application or a few applications. The intention here is that there is the recovery point objective, or there is no data loss because they're writing to the same Ceph cluster. So as long as you cut out one client cluster and then move the workload to the other client cluster, it should theoretically be able to continue from where it left off. So that's where the requirement kind of comes in from. So initially we were looking at the existing block list features and whether we can reuse them in this context. There are a few gotchas. I mean, we're discussing this with Jason and Patrick. So block listing did not fit, and plus we actually want a whole set of clients cut out from the cluster, fenced off from the cluster, not necessarily a client or a big client. The other interesting aspect from the Kubernetes side of things is that we could still have some of the worker nodes in the Kubernetes client cluster continuing to function, whereas their master nodes down. So the volumes could still be mounted, or sub volumes could still be mounted, and IO could still be going on. So we needed something more broader to fence off an entire cluster from access to these F clusters. So okay. So we were discussing that, and Jason came up with an idea saying that, okay, why don't we just knock out the credentials for this FX identity that's being used to mount images from cluster A, client cluster A, and that way we'll take care of all, that cluster will be completely fenced till that particular FX identity is reinstated or its capabilities are reinstated. So there was a problem here in the sense, so we did try that, and it basically works, but there was a problem that there could be outstanding tickets which are still valid, and hence they also need to be invalidated or invalidated. And then Patrick also added a few other cases where there was some Ceph. I don't know these cases very well. He's added the trackers in there. But the Ceph manager and Cephfs interactions needed certain glob-based fencing of certain identities, so that I'm not sure about the use case. I don't want to talk about that. I'd probably goof it up. So based on that, we wrote up this particular. I mean, I wrote up this particular feature request, which is around block list and Cephx entity name by and either a suffix entity name or by a label, and all tickets lower than a particular generation number, so that that's for the third requirement, which I'm not going to talk about. So I just wanted to resync on this and kind of understand if this is the last time we discussed this. There was no problem around feasibility, but then again we didn't discuss this with everybody. So I just wanted to bring this up again. So the first one is the ability to block list or as in the tracker, the ability to block list or unblock list. IO operations, including the current valid tickets. And the next one is to have the ability to add labels to Cephx identities and then block a group of Cephx identities based on this label. So
I think I understand like the use case with Kubernetes here, but that strikes me as having a simpler solution, which is can't we just block traffic at the network layer instead of having the storage system need to do it?
which network layer? Sorry.
I mean, we're talking about a geographically distributed set of stuff here. So like Kubernetes cluster 1 and 2 are going to be at different places, sending routed traffic to a Ceph cluster in a third place, or maybe one of those places. So it's going to be going through routers that can just drop the traffic.
No.
So
the IOs could already be in the queues and the OSDs. It's not that simple.
Yeah, but I mean, but they also could have been committed. Like, what's in flight immediately at the instance the blacklist happens doesn't. That's not a thing we can solve. We can say that by the time
Yes, it is.
the second cluster is made active, the first cluster is no longer sending writes.
No, hang on. That's not what that kind of block list is for. So okay, so we have we have two clients for simplicity purposes, the from and the to, right? So the sequence of operations is block list from, swap to, start IO on 2. What this guarantees is that when the first IO arrives on 2, anything that had been committed from 1 is committed, or not. But after the very first read that Site 2 does, it won't see changes to that, but it itself does changes. So it's not about preventing things that haven't been committed yet from being committed. It's about creating a sequencing point for the cutover. Sorry,
Yes.
go ahead.
Which blocking all the traffic from the from site before you get the to site is activated and allowed to read will do.
I mean, it doesn't, though.
there is also a practical problem here in the sense the management layer that we interact with, it's not like we have access to the route. I mean, this needs to be automated, obviously.
Are you sure? Like, Kubernetes has a whole bunch of networking smarts in it.
No, there are a bunch of different network layers, and they don't all have the ability to do that. I'll just tell you that.
Yeah,
I just bring it up because, like, we can do something like this, but it's going to be immensely complicated and finicky and lots of unpleasant work for many people.
I'll grant you that it's a complicated feature to implement, but conceptually it's not complicated. We distribute an OSD map with enough information to drop IO from the offending client. We know which OSD map epoch it went out in, and IO from the new client will have an OSD map greater than or equal to that.
I understand many possible ways of solving it, but there's a lot of UI, there's a lot of UX. It needs to be,
yes, that's all true.
Not easy to break, and it's going to be a pain in the ass to keep correct.
Yeah, it's a huge amount of work, but it is actually solvable stuff there.
Yes, it's solvable, but it's a lot of work, and for a very specific use case that I think can. And maybe I'm wrong, and if we go away and look at it, then the answer will be no. But Sam, you're concerned about the cutoff point. I understand the theoretical concern you're saying, but that's just not a problem. It is like super not a problem. The queues aren't that long at the places that we would be blocking them from. And it would be, and if we could just black hole network IO, it would be so much simpler and probably safer.
We did look at black holing network IO or set of nodes. We didn't find any convincing answers there that we have access to from the ability to block it. We only now are specifications changing to block a node in a Kubernetes cluster from fencing a node off. That spec is even only now being developed, and that still has a mapping that we need to do between a node identity that Kubernetes thinks of as the node and the actual addresses that the node is using to map volumes and subvolumes. Also, the requirements also that for a given application, its volumes, we may want to cut it off, right? So it's not necessarily the entire cluster that we want to cut off, but only an app that needs to be cut off. So
I'm just thinking about the timelines. I think we maybe downstream want to have a serious discussion about what can plausibly be implemented in what time frame.
So yeah,
because if someone writes this and submits patches for it, I'll look at them carefully, and if they seem maintainable, then that's fine. But I don't think anyone's going to do it quickly. And
so I have absolutely no idea about the complexity that's involved here. Let me be honest. So we never got around to how difficult is this to do. If you're going to say that it is tough, then I definitely like. Are there other alternatives that we can think of here that can make this happen?
For that, I'm with Greg. This is I don't know, a person year and a half of work.
I think if you
Like, you
simplify
could
the
get it in
requirements to
Quincy
say
next year, probably.
only blocklisting the entire cluster, that's much simpler than trying to do blocklist and unblocklist of much finer grained entities and handling the manager failover kind of things.
The finer grained entities I actually have like other problems with, like scalability and size problems.
Yeah.
Whole clusters don't create those problems, so conceptually much easier.
Right.
Yeah.
Right. So among the three, the first one's what the Kubernetes side of things need. But what you're saying is even that's something like a year and a half is what we think it is, which obviously you guys know, right?
So I just want to ask a basic question. So we already have the ability to blocklist clients, right? Now, what if we have something in the middle? Don't have. Let us say we don't have this ideal feature of blocklisting an entity or whatever. What if we have something in the middle that deals or like that takes care of this one client versus multiple clients, and for Rados, it is just going to be issuing multiple block lists for n number of clients versus one client. Is that something that would solve your purpose?
So one of the prerequisites there is to know all the client so it's kind of funny because the kube cluster can still continue doing what it does, the cluster that you're actually trying to fence. So it could reschedule the mount of a volume on another node in its cluster just because it thinks it's up and alive, whereas a higher level management layer has actually taken the decision to move the workloads to the other cluster. So if I'm not wrong, blocklisting is for active connections, right? I mean, it's not for future connections. I mean, it's like
I
blocklist.
believe so. Yep.
Yeah. So it could just move from node 1 to node 2 just because node 1 in that cluster is inactive, whereas like I said, from a higher level orchestration entity, the entire cluster is inactive and the workloads actually moved off to an entirely different cluster. Did that make sense?
Yeah. So it's basically the knowledge of the clients is not, it can change.
It can change. Like I said, we actually have this problem in a Kubernetes cluster as well. The specifications are just now being written for that, but that's another problem that's not. I don't want to confuse that with this one.
Wouldn't there be other kinds of resources in the cluster that you would want to prevent the applications from using?
Sorry, I didn't get that question.
Wouldn't there be other kinds of resources that you want to prevent the applications from using in a failover scenario, and not just storage? Like, for example, if the applications are talking to each other, or
Right. So there are two layers here. One layer is global traffic manager, which actually routes application traffic. So there is within in cluster application traffic that applications can talk to each other, and then for applications that need disaster recovery, the intention is to actually have a global traffic manager which actually routes traffic to these various applications. So that will be flipped from instead of going to cluster A, it will be flipped from A to B, and applications will be moved as a set. So if there was in Kubernetes terms a stateless application that uses another stateful application, which basically means it has mounted storage. They will be restarted on cluster B as a set, and the global traffic the GTM would be rerouted to cluster B. So all traffic now flows to all client traffic to the applications flows through the traffic manager.
I see. So
So
this
there
is
won't be
purely about blocking the potentially still running clients from accessing the storage layer with the even though they're no longer serving traffic due to the higher level switchover.
There are no
right.
other interfaces in Kubernetes that require that kind of a cutover. I know there have been proposed S3 or file system type layers. There's no other persistence layers for which this matters.
There are S3 persistent layers. I mean, there is S3 silent block, or I don't think I understood the question, Sam.
It's the same problem for all of them. So fundamentally, we're talking about what block level requests to RBD, right? Or file level requests, Cephfs, doesn't really matter. Either way, we're dealing with those via Ceph. However, if there were a more generalized S3 available service that an application were using for its persistence, you'd have the same problem. You need to stop the previous defunct version of the clients from updating that shared resource. So are there no proposed ways of dealing with those problems uniformly?
No. So multi-cluster Kubernetes workloads are not something that's prime time yet. So it's there aren't even Kubernetes multi-cluster SIG is not necessarily.
So that raises a question. How does this work within a Kubernetes cluster? If you're migrating a stateful application from one part of a cluster to another part of the same cluster, why isn't this a problem then?
It is. We actually discussed this problem probably a year back. It is. So if a particular node within a Kubernetes cluster is unreachable, for a definition of unreachable, and the application, there is an application with a mount point running on that node, it will be rescheduled subsequently on another node. So there are two levels of protection there, but it's just time. One of them is that it just waits 5 minutes before a node, which is the configured default timeout, before the node is deemed dead, and an additional 6 minutes for the volume to detach. But there was no mechanism in Kubernetes to actually inform storage that a particular node is dead and it needs to be fenced. The spec so this has been a problem, and the spec for this is, as we speak, being written. I mean, I think it was rolled out a week and a half back, where the control plane will be notified that a particular node is dead, and that will subsequently notify the storage orchestrator,
Okay.
which will
So
then.
It's already a problem, but the control plane is unable to see it. So it's entirely unfixable for Kubernetes right now.
Right now, and this specification.
Yeah. What I'm saying is this problem you're trying to solve for cluster migration is present for regular clusters just as severely. Okay.
Yes. But
So
I'm
why is
going
it
to say
more
that in
noticeable for cluster migration? Is it more noticeable, or is it just that it's more fixable from the Kubernetes standpoint?
It is possible to implement client applications in pods that handle this correctly, whereas it is not currently possible to implement Kubernetes multi-cluster that handles this correctly. I think is the answer.
How do you do the former?
The client can do things in its pods, like RVD volumes are fenced using the existing RVD fencing mechanisms.
It should be the same. That shouldn't work, right? Because you can only fence the whole client, not just a particular instance.
Yeah, you can fence particular instances.
So why doesn't that work for the cluster migration one?
Because you need to know all the instances.
And that's not possible?
No.
Even fencing an instance is work in progress in Kubernetes. It's not done yet. Just saying. Just repeating myself.
Okay. OpenStack does it. It is a thing that Ceph provides tooling for, and that sufficiently intelligent clients can do within their pods if they want.
This is even simpler. Whatever unit you're using to transfer these things, we could add a feature to RBD that lets you just write down the client instances.
Well,
read them back on the other.
Because that's not scalable.
Why not? You can start it over as many Rados objects as you want. It's extremely scalable.
No. Block lists are part of the OSD map, Sam.
I know. That part is, yes. But apparently we already solved this problem within a Kubernetes cluster using. So to the extent that it's a problem, it's already a problem. This wouldn't be any worse.
It's a question of inherent scale.
The problem is that
within
when you
a
lose a whole
node,
cluster, the inherent number of instances is too big. That's the argument.
Yes, when you lose a node, you need to put one node's worth of client instances in the block list. When you use a cluster, it's an entire cluster's worth, just automatically.
I wonder how big that set actually is and whether an intermediate version of this problem wouldn't be fine. That actually does have scalability problems, but whatever.
The scalability problems would be a lot less if we added the command to allow you to blocklist a bunch of entities at once instead of
Right.
adding a new OSD
More than
epic
that,
each time.
what I would feel more comfortable with is that we could block like IP ranges. With some kind of epic that I think would take less time. I mean, I'm looking at the way the is blocklisted code works, and
we can make the block list
perfectly reasonable
better once. But so I think we have two different distinct problems. One is that we don't know the instance list for whatever reason. I think we can solve that problem via whatever means. It doesn't seem conceptually hard. And use the current unscalable commands that already exist in Ceph to just do it. And then orthogonally to that, we address the fact that the way we're doing blocks for Kubernetes isn't very scalable. Like if Kubernetes has its own
I think that allowing you to block IP ranges would be the way to solve the scalability problem.
Right, but that's not the immediate problem. The immediate problem is that this feature doesn't work in Kubernetes. It's not that it's not scalable; it's that it's not possible.
Yes. So initially we were thinking about the IPs and just getting all node IPs and things like that. But I'm not so sure that so within a Kubernetes cluster, a node having a node and pods having unique IPs is guaranteed. But across kube clusters, I'm not so sure it's guaranteed. So now the point is, if you blocklist a range of IPs and the other cluster reuses those because it's I don't know whether that'll work. That's one of the problems something that I need to find out.
Okay. Well, having told you that the earliest we could do any version of these things that you talked about is in a year, maybe. We could do IP range blocklisting much more quickly if you're convinced it was useful. And I mean, I'm talking about like however much range is needed, but like a /16 or whatever. Like we would probably do is literally encode the number of bits it needs to match, and then the starting and ending ranges, or the start range or something.
So the IP ranges, I'll tell you this. I mean, so yes, it's definitely tempting, but then there is the requirements back.
I mean, if they're reusing them, then yeah, I'm just telling you, this is one that you might be able to get in a time frame that is useful to you, unlike the others.
Fair enough.
At least the deployments I've seen, that categorically won't help.
All right. Well then, yeah.
It's just not the way networking usually works.
You can't configure it to start at an IP point?
Sure, you can, but there's absolutely no reason to assume that two different clusters will have well-defined blocks or that they'll be non-overlapping with other resources.
Okay, but if we're like setting up a multi-site cloud thing designed for this failover to work, that's a constraint we can enforce, right?
If we were setting it up, sure, but we're not.
Yeah, that's what.
Well, I think it Shamsuddin. I'm sorry when I say your name.
Sham.
Okay. Well, in his case, I think we are setting it up. Like, right? This has got to be for OpenShift. I assume.
It is for OpenShift. We
can document like these are the requirements if you're not using like for upstream Kubernetes and upstream Ceph. We could be like, here are the rules.
Actually, I take back what I just said. Now that I think about it, even having two different Kubernetes clusters addressing the same Ceph cluster creates really weird constraints in the networking already. They all have to be layer 3 routable to each other, which isn't generally true in Kubernetes clusters. That's weird. So, I don't know, maybe it's not totally crazy.
Yeah.
Is that really a common configuration where you have two totally distinct Kubernetes clusters that are routable in this way? Like the routing requirements for Ceph are draconian. Every client needs to be able to talk to every OSD directly. You need to be able to set up a direct TCP connection. Like, it's pretty extreme. You wouldn't have two separate Ceph clusters?
I think you're asking about what exists, Sam, versus what we're going to make exist.
Yeah, the two separate Ceph clusters is a different one where we don't need to fence off in this fashion because, for example, both RBD mirroring and CephFS mirroring have a notion of primary and secondary, and so it'll just split brain and the orchestration layer will have to decide who's the which one has the real copy and resync it in the other way. So we're okay there actually. We're good there. The only use case that I know is an external Ceph cluster shared by multiple OpenShift clusters. The only use case that I know of is an external Ceph cluster shared by an OpenShift cluster. This whole multiple clusters is something we're attempting to do. So I don't have an answer to your question. That's what I'm saying. Okay. So the FX identity and feature there is going to take a long time. We probably need to, I probably need to figure out if we can block list a range of IPs or a list to begin with a list of IPs. Then we can talk about a range of IPs because that feature doesn't exist yet in Ceph. So, and we see where we go from there.
Or even start with the basics of trying to use existing block list commands even, trying to get the list of instances.
Like if you just remember the set of instances associated, that would do the job. It would be a little inefficient, but whatever.
Yeah. A list of instances and then range and then.
Yeah, like if these are small clusters and we know the IP addresses then that are available to them, then
it's not even that the cluster has to be small. It's that the set of pods speaking directly to Ceph has to be not that big. And not that big means hundreds is probably fine. Like
maybe
these are gateways probably that serve a much larger set of the actual application pods, I would guess. So the scalability problems here may be less severe than they look. It depends on how the application is architected.
Yeah. Well, I mean, I think most of them are mounted on the host. So it's just the host IP, but I could be misremembering how that's partitioned.
But this really may not be a big scalability problem. This may be not a big deal at all, actually.
Okay. So it is the host that mounts. We verifying one or two things. A couple of days back, we had another meeting. We're verifying one or two things around that, but it's the host that mounts. And for the pods, they just bind mounted into the pods. So we're not so worried about pod IPs yet, but we need to confirm that.
Yeah. So a lot of the RBT tooling that you're probably referring to is set up to do specific instances because it was designed for OpenStack where things were mounting as like part of a QEMU KVM process. But you can also just blocklist an IP and it's stuck blocklisted until it might be a default 24-hour time limit or whatever, but either you can refresh it or it's stuck blocklisted until you unblocklist it. So if you know the number of hosts and their IPs, that works the way, I don't know what scale, but a large enough scale for many Kubernetes clusters that I've heard of us deploying.
Okay.
The more complicated things you're talking about here are like I said, a lot harder.
Okay. Well,
that helps. If you guys have upstream meetings you want us to come and talk about this at, or downstream ones from Red Hat, I'm happy to do that.
Sure. I'll keep that in mind. I mean, this is a little down the line. I'm just.
I think the main thing to remember is what is the scale we are looking at, and what is the timeline, right? We don't need to come up with the perfect solution in 6 months. We can come up with the perfect solution in 2 years. But the point is, what is the minimum viable product you're looking for in what time frame? If you can get those straight to us, then probably we'll be able to guide better. At this point, we are like, okay, this is a possible solution and this is the best solution, but we can pick something in the middle.
Okay. I'll probably do that. Yeah. Actually, that's where we started, and ended up with this tracker. But we'll redo that conversation. It's totally fine. But I mean, thanks for a realistic effort estimates, because that decides what we want to do as well. So that helps.
All right. Anything else on this topic? Okay.
I'm good. Thank you.
Thanks for bringing it up. Any other topics folks want to discuss?
Yes, George. I just add a very tiny topic. It's a follow-up of the last discussion over the CDM.
Mm-hmm.
Over the discussion of the regarding to the collecting the slow request in manager, because in last discussion we mentioned that let all the class log going through the Texas could be hurt the performance of the monitor. In the case when the cluster is suffering from the performance issue, we don't need to burden it with more load with processing the cluster log. So this last time our solution was to use the health protocol to collect the summary of the health reports and let the manager to aggregate summary, and then enable the manager to collect the details from for example, the OSDs and the MDS statements for the exact slow request. So the Ceph CLI could collect, or dashboard could ask the manager for the more details on demand. But when looking into this problem in depth, I realized that there is some problem we need to solve. The first one is what if the manager, the active manager instance fails? Because before that we are using the RocksDB for persistenting this cluster log, but the manager does not have this facility at this moment.
But yeah, I think the basic point is that we don't need all this information for debugging, and so we're trying to summarize it. And I think part of that also means we don't even need it to persist necessarily. Like it's helpful to understand what went wrong at the moment. But if the manager happens to go down, I don't think we need to worry about trying to collect this information again, because if the slow requests are still happening, then they'll still be sent again. And if they're not, then there's not much more diagnosis that we can do at that point.
So we're fine if the messages, the slow request details go with the failed active manager instance.
Yeah. I mean, they also show up in the OSD logs themselves. So we have a persistent copy on the OSDs where they were created originally.
And I mean, we're not removing the slow requests or the slowness reports from the monitor. It's just about how much detail is in them, right?
Exactly.
So. Yeah.
No, we are removing them from the monitor. We are aggregating them on the manager side.
We're still having the aggregate report in the monitor log, but we're not having any of the individual request reports.
Yes. So the point of this change is to collecting all of them on the manager side instead of on the monitor side.
Oh, but the manager is intermediating all of them.
Yes.
So if manager's down, we just lose it completely from the monitor. Okay.
I mean, if the manager's down, you already lose a lot of Ceph status. So I think we've gone way past that point. It's not.
I just still like our little vision where if the cluster would run, it just wouldn't change itself.
We did talk about having a summary in the cluster log as well, right? I mean, so if we have few data points, in different places, we should, that should be good starting points. I don't think we even at this point we log so much of slow request, but we're not probably looking at everything. We're probably looking at when it initiated and how long it lasted, right?
Yeah.
So.
Yeah.
That reminds me, actually, I had an idea when we were investigating a recent issue when we were able to tell what was blocking the slow request based on the TQ latencies. In order to make this easier to diagnose what was ended up blocking, we could have right now it's very difficult to tell from the existing information what is causing a slow request. If we had a sort of cache of what the recent ops were for each shard, when the TQ latency has a spike, we could record that in the cluster log or somewhere, record that somewhere, at least in the OSD log, and print out what the most recently processed ops were, since they were probably the culprit of that large blockage.
I agree that it's important for looking into the issues. But another question is how many slow request entries? How many entries of a slow request reports should we keep? Presumably, it should be configurable, right? Instead of keeping all of them in.
Yeah, we certainly don't want all of them.
Yeah, I don't think we want to keep all of them. We can keep a count of how many of them are there, right? Like how many, just the count of like how many slow requests over time have we seen? If it's like, audio
number.
Yeah, exactly.
And we should keep them in the memory or local storage like SQLite DB in manager.
In memory, it doesn't need to be persisted again.
Okay, cool. So problem solved. Thank you.
Sure. Okay. Any other last minute additions? All right. Thanks, folks. See you next month.
Thanks. See ya.
Thank you.
Thanks. Yeah.